Hello folks, in this video we're going to start two-dimensional motion. The way this works in this unit is that we do general two-dimensional motion for this video, and then the main event for this last section is projectile motion, which is just a special case of two-dimensional motion. So in the video you just watched on two-dimensional vectors, on vector components, we talked about objects that are moving at an angle relative to our axes and how there are two components for whatever vector you're thinking about. I want to give you an example before we get started. So imagine that you're walking down a hallway and you're walking straight down the hallway. We'll imagine that that hallway points north because that's where we're looking on the piece of paper. And then you make a turn to go west. Imagine you're coming out of our physics classroom and you're headed to English or Spanish or history class or art. And you have to take a left-hand turn. And at this moment in time, you are no longer moving on the y-axis, north. You are no longer moving on the x-axis, or you're not yet moving on the x-axis, west. You are doing both. And so two-dimensional motion is just any object that's moving in more than one direction at a time. This is essentially meaning any object that is moving at an angle with respect to whatever axes we have set up, typically up and down and left and right. The most important thing about two-dimensional motion is this idea. The x and y direction behave independently. I'm going to do a demonstration in class to help show you this, but physics works much more easily if we separate motion into two dimensions separately, so the x direction and the y direction. And so the reason that you did the trig in the previous video is so that you know how to separate motion into two directions simultaneously. I'm going to teach this just with an example. This example will not involve any trig, and you can imagine that the trig has been already done or taken out of this problem. And we'll introduce the trig when we get to projectile motion. So here's our example. A ball rolls north with a velocity of 5 meters per second, and the wind causes it to accelerate at 1 meter per second squared east. Calculate the ball's northward and eastward displacement after 4 seconds. So the initial motion of the ball is north, and so on our paper that's up. And then because of the wind, there is an acceleration to the east, and so that's going to introduce another dimension of motion. Now, in two-dimensional motion, acceleration can happen in any direction or not at all. And so this is just an example that has acceleration in it. Calculating the displacement is a matter of using a kinematics equation to determine how far something has gone. And the key here is because there is motion in two dimensions that we handle things separately. So we're going to do the y direction first. And the y direction is simpler because the initial velocity is 5 meters per second. That's north. The time is 4 seconds. And then here's the key. Because the acceleration is happening to the east, there is no part of that acceleration that points north or west. When things are separated by 90-degree angles, they do not interact with one another. So there is no way for this acceleration to affect this velocity. And so that's the key to all two-dimensional motion, is to separate your vectors into perpendicular components. So the acceleration is going to be 0. And we are looking for the displacement. So this is really easy. We use our kinematics equation. This first one, or this one that I'm using now, is I think the second one in your notes. But this equation is the only one you want to use when the acceleration is 0. Here's why. If the acceleration is 0, this term, 1/2 at squared, will cancel to 0. And so you will be left with displacement equals velocity times time, which is, if you learned it this way in middle school, distance equals rate times time. So this one equation is good for all constant velocity motion. So the delta x is going to be 5 meters per second times 4 seconds, or 20 meters. Okay, so that's in the gosh, sorry, that's in the y direction. Sorry, I did this backwards. So you're going to live with the error. So one thing I wanted to share, which I accidentally shared now, is when you're moving in 2 dimensions, you can switch all of your x's to y's to accommodate whichever direction you're looking in, and to keep those variables separate. So this is delta y because I am working in the y direction. Next and last, we do the x direction. And so the x direction has a whole different set of values. The only thing that's consistent is the time is going to be 4 seconds. Now you will find that time is always consistent between the 2 dimensions of motion because it has to be. There's only one event here. This ball is rolling and we're looking at where it's gone after 4 seconds. And so the amount of time has to be the same for both. The acceleration is eastward, so positive 1 meters per second squared. And then we come back to our idea of the x and y variables don't affect one another. The initial velocity in the x direction is 0 because this 5 meters per second is directed north, which has no components in the east or west direction. So initial velocity is 0 meters per second. And again, we're looking for the displacement. So this time I'm going to keep it as delta x. And I'm going to use the same equation because I have the same variables that I know. They're just different numbers. This time something else happens. The initial velocity was 0, so v naught times time will cancel to 0. So I have delta x equals 1/2 1 times 4 squared. And so this, did I get that right? Yeah, I did. Okay. This time, the final value 16 is 4 squared times 1/2 is 8. And so it goes 8 meters in the x direction. And so this is the answer to the question. So this ball has traveled 8 meters to the east and then 20 meters to the north. And so if I imagine, right, like on my picture here, after 4 seconds, the path that this ball has taken, it started purely north, but then this acceleration has driven it to the east. So after 4 seconds, the ball might be there, having gone very far in the north direction and a little less far in the east direction. So we don't do too many pure 2-dimensional motion questions outside of projectiles. And so this is like your one example for now. I will downplay this in this unit. We might come back to it when we're reviewing for the AP exam to just expand our understanding. But that's it.